Can a person's experiences on Earth alter how they perceive the stars? Lauren Colley peers through the telescope of Anton Pannekoek, the Dutch astronomer whose politics informed his human approach to studying the cosmos. You are false images. Faces of radiant flame. Heart's warmth and tenderness. And soul you cannot claim. Karl Marx. Song to the Stars. 1836. In the many drawings that Dutch astronomer, Marxist thinker, and council communist Anton Pannekoek, 1873–1960, made of the Milky Way over the course of his life, it is not immediately clear what we are looking at. The band of stars appears like a smudged backbone, sometimes in true color, white stars on a black background, and sometimes inverted, with the stars as dark points and the milk of the Milky Way made inky. They are simultaneously vague and precise, something between a charcoal rubbing and an X-ray. In fact, the drawings are not technically of the Milky Way at all, because according to Pannekoek, such a thing was not actually accessible as a purely objective entity. While it was widely understood in Pannekoek's time that even highly skilled astronomers fall prey to observational bias during stargazing, a phenomenon known as the personal equation, Pannekoek went further, theorizing that what we perceive as the Milky Way is actually a visual trick that emerges at the intersection of the stars and the people on Earth who perceive them. During an article published in an 1897 issue of Popular Astronomy, Pannekoek discussed the well-known problem of the Milky Way's ocular inconsistency, wondering if the character of the galactic phenomenon precludes its being fixed by delineation. This was not just a failing of observational science. It reflected what the Milky Way actually was. A kind of optical illusion that changed its shape depending on the lived experiences of the observer, their historical period, and how these experiences informed the patterns that the mind constructed out of the fluid nature of reality. Pannekoek's drawings, then, are of the act of perception itself, an approach informed by his political beliefs. Like Marx and Engels, who drew on Feuerbach, Hegel, and Heraclitus, Pannekoek understood material reality to be a continuous and unbounded stream in perpetual motion. He also believed that the human brain had a tendency to generate fixed, abstract patterns from this fluidity, patterns that are always socially and historically contingent. Any view, including that of the stars in the sky, was therefore always making and remaking itself in the mind of the observer according to their individual physiology, psychology, and the distinct material conditions of their place and period. As technologies for image-making, such as radiotelescopy and gamma-ray instruments trained on the Milky Way, become more advanced, mechanical objectivity does not necessarily become more trustworthy. Quote, history of astronomy has been commonly narrated through the technologically determined progression of better and increased vision. Writes Anya Ventura. 4 Yet because these technologies rely on a form of data gathering beyond the faculty of the human senses, there are always additional processes needed to transform their findings into something we can experience. These processes, often excluded from the public-facing narrative, or shot through with subjective decisions. The rich milky vistas of turquoise, rust, violet, and crimson that populate NASA's first Hubble telescope photos, for example, were artificially colored, much to the disappointment of a public who felt they had been tricked. The Hubble website responded that artificial colors allow viewers to visualize what ordinarily could never be seen by the human eye. As Lorraine J. Daston and Peter Gallison have argued, scientific imaging's objectivity rests on a construction of the naked eye as deeply unreliable. Pannekoek's drawings, by contrast, produced during a period in which the mechanical eye was overtaking the traditional role of handwork in astronomical observation, represent an alternate current in astronomical image-making, one that does not shy away from the inherently contested and personal nature of viewing space, but builds this contestation into its very method. This way of doing science does not deny its embeddedness in the material and historical conditions of living on Earth. Born in the Netherlands in 1873, 25 years after the publication of the Communist Manifesto, Pannekoek studied mathematics and physics at Leiden University, publishing his first paper on the Milky Way while still a student. He became interested in socialism upon reading Edward Bellamy's utopian novel Equality, 1897, after which he began to study the philosophies of Karl Marx and Joseph Dietzgen. His scientific and political careers proved difficult to reconcile, and he eventually left his job at the observatory after he was reprimanded for supporting a strike. Deciding to devote his life to revolutionary politics, he moved to Berlin and then Bremen, where he published widely, often with a pseudonym, and taught classes on historical materialism at schools founded by the German Social Democratic Party, SPD. He had an intercontinental reach. In the years before World War I, Pannekoek's name was familiar to many American socialists when Lenin and Trotsky were virtually unknown. Notes Theodore Draper. After World War II, disillusioned with the communist states, he became one of the main proponents of council communism, a current of thought that opposed state socialism, and instead advocated for a revolution led by the workers' councils. Despite receiving a favorable treatment in Lenin's The State and Revolution, 1917, Pannekoek is perhaps best remembered politically for his 1938 Lenin als Philosoph, Lenin as Philosopher, which critiques the revolutionaries' belief in the reality of abstractions. Pannekoek returned from Germany at the start of World War I and found himself once again at Leiden University, where he gradually resumed teaching duties. After a change in the university's directorship, Pannekoek's name was eventually put forward for vice-director of the observatory. But his known communist activities meant that the Dutch government, fearful of the tide of communist revolutions sweeping across Europe, vetoed the appointment, as though his propaganda activities might be a risk to the stars. In 1921, Pannekoek established the Institute of Astronomy at the University of Amsterdam, which bears his name today. Around the time he was first dismissed, Pannekoek had described the university's methods as tedious and outdated. Astronomy at the turn of the century was committed to its self-fashioning as a precision science, and doubled down on its acknowledgement of the personal equation problem by building vigilance, monitoring, and bookkeeping into methods. William Ashworth describes this as an accountant's view of the world. Pannekoek, by contrast, argued that the Milky Way was produced at the intersection of physical reality, the observer's eye, and the way their mind interpreted this interplay. In A History of Astronomy, 1951, Pannekoek asks, "What really is the Milky Way? Exactly speaking, it is a phantom, but a phantom of so wonderful a wealth of structures and forms, of bright and dark shapes, that, seen on dark summer nights, it belongs to the most beautiful scenes which nature offers to man's eyes. It is true that its glimmer is so faint that it disappears where the eye tries to fix upon it. It is perceived only by the rods, not by the cones of the retina, hence is seen only by indirect vision. Yet, when all other glare is absent, it gives an impression of brilliant beauty, because of the faintness of some stars that made up the sparkling band of the Milky Way, and the unpredictable way in which the human eye received their light." Pannekoek believed that the brain, which tended towards abstraction, found its own patterns in the interplay of light and dark, and that these patterns would be different depending on the distinct life experiences of the observer. Pannekoek devised a method to produce what he termed the mean subjective image of the Milky Way, which was comprised of multiple layered perspectives. To achieve this, he collected accounts of the Milky Way perceived by several other observers, initially as written descriptions, believing that sketches were more likely to lose their accuracy in the act of drawing, and later also as extrafocal photographs, where the plate was intentionally placed outside of the focal plane so that light was distributed more fully, mimicking the way astronomical light is perceived by human eyes. Both the written accounts and extrafocal photographs were translated into isophotic maps, which correspond to the intensity of light. Similar to how topographical maps capture the height of terrain, a line was drawn around an area of equal luminous intensity. Each line was then ascribed a value. The mean subjective image was produced by finding the numerical average of each shaded line. Once the average had been calculated, the maps were made into drawings by Pannekoek himself. Pannekoek's disavowal of the idea of special scientific genius did not discount the value of acquired technical skill. Omar Nassim has explored the way Pannekoek's scientific practice centered on craftsmanship and handwork, what Nassim calls a strong operational presence of the hand, highlighting how different forms of labor are involved in the production of scientific knowledge. In this sense, too, Pannekoek brought down to earth the mystified discipline of astronomy, which, as Nassim writes, does not have the luxury of having its objects near, highlighting the material conditions that made astronomical ideas possible. Though Pannekoek lived and worked two distinct lives that he was never fully able to reconcile, he is increasingly remembered now as a Marxist astronomer. The resurgence of interest in Pannekoek's dual pursuit seems tied up with an increasing awareness of how science and systemic violence intersect, prompting the question of how we might do science differently. What might a science informed by socialist politics look like? And where are the Marxist scientists today? Modern astronomy is far from a politically benign pursuit. Its development in Europe is closely bound to the emergence of systems of global data collection, mapping, and standardization that exploit material resources from across the globe while also positioning Europe as the intellectual center of the world. As Alex Soojing Kim Peng argues in Empire and the Sun, Victorian solar eclipse expeditions, astronomical research became a way for European countries to impose Western scientific norms and beliefs as objective truth. It was common practice for European universities to build observatories in colonies in the southern hemisphere, which offered a different view of the night sky. Pannekoek himself benefited particularly from colonial infrastructure in Java and Sumatra, at the time part of the Dutch East Indies. Nevertheless, the philosophy underpinning Pannekoek's work, when examined critically today, might be said to contribute to a current of scientific thinking that subtly undermines the forceful imposition of certain worldviews over others that has largely been the legacy of colonial knowledge production. A dialectical view of the night sky opens up a path beyond any absolute binary between truth and falsity, evoking a form of scientific rigor and precision that does not aim to present itself as complete or incontestable. Pannekoek's drawings therefore hark back to an earlier form of astronomy which, as Charlotte Bigg writes, embraced a qualitative, literary and aesthetic approach rather than a quantitative, mathematical approach to phenomena. By foregrounding interpretive variety, Pannekoek edges towards a more bottom-up and decentralized way of doing science, one that has the potential to complement anti-colonial and anti-capitalist methodologies. It was their quality as aesthetic objects that first captured my interest in Pannekoek's sketches. And I'd guess that this is also what has helped these sketches to endure. The aesthetic realm, for Pannekoek, was a manifestation of the way in which the human mind is able to build order out of the disorder of the cosmos. As Johann Hartl writes, this idea of a profound isomorphism between cosmic order, nature, human society, and even the individual subject, held the promise of a society based on a self-regulating system of material forces. The Milky Way images, then, are not images of the sky so much as cosmic mirrors for the human subject, revealing the interplay between the individual and the collective, between thought and matter, and the deep correspondence between art, science, and politics. Lauren Colley is a writer and doctoral researcher looking at the dark sky movement at Goldsmiths, University of London. Her essays and short fiction have been published in Real Life Mag, Another Gaze, Overland Journal, Uneven Earth, and more.